Today we're going to be learning about a really mysterious and kind of magical quantity in linear algebra, and that is called a determinant. A determinant is a quantity that will tell us whether or not a matrix is invertible. It'll tell us about our eigenvalues and eigenvectors, and it'll also just give us some more useful properties of the matrix that we're dealing with. So we're going to start first with a determinant of a 2 by 2 matrix, because our 2 by 2 matrices are our building blocks for the determinants of any kind of size of matrix. So let's first master the basics. So if we want to find the determinant of A, we denote it det of A, short for determinant, or we can also denote it with the bars that kind of remind you of absolute value bars, so it's just the two straight lines on either side of the matrix that you are trying to find the determinant of. And that's going to be equal to, we're going to take the product of the diagonal going from left to right, A times D, and then we're going to subtract from it the product going from right to left, so BC. So then this is what our generic formula for a determinant of a 2 by 2 matrix is. See, nothing to sweat about. It's pretty simple. So let's look at it in context of an example. So if we have a matrix A, let's say we have 3, 1, -2, and 6, and we want to find the determinant of this. We are going to take the product of this diagonal here, take the determinant of A, it's going to be equal to this product, so we're going to have 3 times 6, and then we're going to subtract from that the product of the diagonal going the other way. So this product. So we'll have 1 times -2. So we'll see our determinant A is equal to 3 times 6, which is 18, minus -2 times 1 is going to be a -2. So we're going to see that our determinant of A is equal to 20. So if you haven't quite mastered this basic skill yet, no worries. In cofactor expansion, which is how we're going to find our determinants of n by n matrices, we're going to be going back to the determinants of a 2 by 2 matrix quite frequently, because this is the building blocks that we build all of our determinants from. So basically, we have to learn how to ride a bike before we can do a flip on a bike, right? So now we needed to learn how we could take the determinant of a 2 by 2 matrix before we could flip into matrices of larger sizes and finding their determinants. But I think we've mastered this so far. So let's put this into action and flip on into n by n matrices. So now to find a determinant of a n by n matrix, we have a special method called cofactor expansion. I want you to keep in mind, as we're finding the determinant of an n by n matrix, that we can only find the determinant of a square matrix. So we're defining it for an n by n matrix because that's the only kind of determinant we can find. So let's look at our cofactor expansion. First, we need to define what a couple words mean. So first, our cofactor is this. So our cofactor is a value associated with an element of our matrix, A sub ij, and it's denoted C sub ij. And this C sub ij is equal to -1 raised to the power of the sum of the row and column that A value is in, and we're multiplying that by the determinant of our minor. Okay, wait, so now what's our minor? Our minor is, an n-1 by n-1 matrix corresponding to one value of our original matrix here, A sub ij, such that we have deleted the ith row and the jth column. So we are deleting the row and column that this A sub ij value is in. Now that we know what a cofactor and a minor are, we can get into our cofactor expansion. So in our cofactor expansion, we can either expand along a row or we can expand along a column. So let's suppose we want to expand along row I. Then the determinant of A is going to be equal to the first element in that row, so it's going to be stored in row I in the first column. We're going to multiply that by its cofactor, C sub I1, and add it to the next element in that row, a sub I2, and multiply that by its cofactor. And we're going to keep on doing this, and then until we get to the last element in that row, a sub in. We're going to multiply that by its cofactor, right there like that. So let's look at if we wanted to expand along column J. So then we know the determinant of A is equal to first element of column J. So we're going to have in the first row, jth column, and its corresponding cofactor, and add it to the next term in the column times its cofactor. And then we're going to keep on doing that until we get to the last term in our column. Oops. That's going to be A sub nj times its cofactor here. So these are our two cofactor expansion methods, either by row or by column, and it can be any row or column in our matrix. So I know this is a little abstract, so let's look at it in context of an example. So let's find the determinant of this 3 by 3 matrix. We have A is equal to 1, 2, 1, negative 1, 3, negative 2, and 3, 1, 1. So now we know to find our determinant of A, we can either expand along a row or along a column. So let's just for kicks and giggles choose the third row here. So we will know that the determinant of A is equal to the first entry in the row that we are expanding along. So we have 3 times its cofactor. So that is going to be C, and it's going to be in the third row, first column. And then we're going to add that to our second entry, which is 1, times our cofactor in the third row, second column, which is where this 1 came from. And then add that to our last entry in the row times its cofactor, which is C33, third row, third column. And now we can expand this out for our cofactors here, and we'll see that we have 3 times negative 1, we have 3 plus 1 power, times the determinant of the minor once we take out this A sub 3, 1 term. So then we're going to get rid of our first column and our third row. We're going to be left with this matrix up here. So we're going to have 2, 1, 3, negative 2. And then we're going to be adding that to 1 times its cofactor. Negative 1 to the 3 plus 2 power times the determinant of its minor. So we're deleting the third row, second column. So we're going to have 1, skip column 2 because we're deleting it, 1, negative 1, skip the second column, and then we'll have a negative 2. And then we're going to be adding this to our last entry in the row times its cofactor. So we have negative 1 raised to the 3 plus 3 power, because we're in the third row, third column, times the determinant of its minor. So we're going to be deleting the third row, third column, so we're going to be left with 1, 2, negative 1, 3. Okay, so now we have a lot of determinants to find and simplification to do, so let's dive right in. We have A, our determinant of A is equal to 3 times negative 1 raised to the 4th power is just going to be 1, so we just need to take the determinant of this. So we're going to have 2 times negative 2, diagonal going down that way, minus the determinant going down the other way, or the product going down the other way. So we have 1 times 3. And then we're going to be adding it to 1 times, okay, so this one is a negative 1 because we have negative 1 to the 5th power. And then we're going to be multiplying that by this determinant. So we have, going down from left to right, 1 times negative 2. And we're adding that, or subtracting from that, our negative 1 times 1. That's going to be that determinant. Okay, and we have 1 turn left to do. We can do it. We're going to adding 1 times negative 1 to the 6th power is just 1. So we're just going to take 1 times the product of this determinant. So we have 1 times 3 minus 2 times negative 1. Okay, so now all we have to do is simple algebra, no more determinants to take, and we'll have our determinant of A is equal to our determinant is equal to negative 15. Okay, so now we've successfully found the determinant of this 3 by 3 matrix. And I like to say that we pretty much rocked that. So let's test ourselves and try a 4 by 4. We have been presented with this 4 by 4 matrix here, and we are going to make a smart decision about what row or column that we are going to expand along to make our job a little bit easier, because this is a lot of determinants we're going to have to take. So our second row has 2 zeros in it, as well as our second column. So let's choose our second column and expand along that. So we're going to take our determinant of A, and that is going to be equal to the first entry of our column times its cofactor. So its cofactor is going to be negative 1 raised to the sum of its row and column. So it's in the first row, second column. And it's going to be multiplied by the determinant of its minor. So we're going to be deleting the first column and the first row. So we're left with 2, skip the second column, 1, 0, and then 0, skip the second column, 1, 1, and then negative 2, skip the second column, 2, 1. And then we're going to be adding that to the next term. So we have 0 as our next term. This is where it helps us out, because then our cofactor of 2 is just going to end up being multiplied by 0, so we don't actually have to worry about calculating that segment right there. We're going to be adding this to the next entry in our column, which is 1 times its cofactor. So we have negative 1, and it is in the third row, second column, so we have the 3 plus 2 power, times its minor. So we're going to be deleting the third row, second column. So we're going to have negative 1, skip column 2, 2, 1, 2, skip column 2, 1, 0, and then skip the third row, and then we'll have negative 2, skip column 2, 2, 1. Okay? And then we have one last term to include in here, and it's going to be, once again, a 0 as our last term in our column. It's going to be multiplied by its cofactor. So, unfortunately, like we know, we don't have a super easy, simple formula for our 3 by 3 matrices, so we're going to have to break these two into a bunch of 2 by 2 determinants. So we're going to use our cofactor expansion within these as well. So let's take our A determinant is then going to be equal to 1 times, we have our negative 1 raised to the third power, so that's going to be a negative 1, times this determinant. So now we are going to expand along one of the rows or columns. So let's expand along the second row here. Okay. Now luckily this term right here is going to be a 0, so now all we have to deal with is our last cofactor expansion here. So we'll have 1 times negative 1, once again, is raised to the fifth power, which is an odd power, so we're going to have a negative 1. We're going to be multiplying that by the cofactor expansion of this determinant. So let's expand along our third column here. So we're going to have okay. Ooh, that was a lot. So now, I have faith in us, we can still do this. So we're going to take the determinant of A, and that's going to be equal to, I'm just going to go ahead and solve this. Okay, whew. That was a lot of algebra. So we know now that our determinant of this 4 by 4 matrix is negative 15. So I challenge you, if you're really feeling risky this afternoon, you can go through and try in a different row or a different column and see if you can come up with the same answer. So that has been determinants, and we'll see you next time. Have a great day.